Okay, let's have a quick read of this question. Question 14. A particle P of mass 1 kg is projected up a line of greatest slope of a rough plane inclined at 30 degrees to the horizontal. The initial velocity is 8 meters per second. The particle comes to an instantaneous rest on the plane after 4 meters. Calculate the friction force acting on P, coefficient of friction between P and the plane, and the coefficient of friction. Okay. Determine the acceleration of P down the plane subsequently to the instant of rest. Okay. Right, so let's just draw a little diagram. Always draw a diagram. So this is the horizontal, and this is a slope which is rough and it's inclined at 30 degrees. Okay, and P is projected up here, which has a mass of 1 kg. So the weight acting right down is 1g. That's going to be, now it does say it's a rough plane, so let's just do the components. We're going to work with the line of the slope, so that's going to be 30. So the action going down is going to be 1g, opposite that, so that's sine 30. So that's going down here, and along here it's going to be g cos 30, and that's going to be direction, well, contact force of that reaction force. Okay, so that's going to be going up. Okay, so it's been projected up with a speed of 8 meters. So the initial u equals 8 meters per second, and then as it goes through comes to a rest, and so it's telling you it's kind of, so it's being projected upwards. If it's going in that way, friction is going to be opposing it, so friction is going to be slowing it down, going that way. Okay, so right, before we go through here, let's have a look what we can use, what we got from Savat. We know it starts from 0. No, it doesn't. It's projected at 8. Okay, we know that the particle comes to instantaneous rest, so the final velocity is going to equal 0. We know that's going to happen 0 after the displacement is 4 meters, and I want to find the acceleration in order to find further things, so find the friction force. So we need to find that. So this is Savat, and if you got UVSA, so we can use the formula V squared minus U squared equals 2AS. Okay, and we need to find A, so that will be V squared minus U squared all over 2S will give me the acceleration. Now I know that from here I can just sub those values in, so that will be 0 squared minus 8 squared divided by 2 times 4, and that will give me minus 64 over 8. That'll give me minus 8, therefore acceleration will be minus 8 meters per second. So as it's going up, as it's projected, it's decelerating at 8 meters per second. Okay, so now because we know that, we can now start working on the resultant force here and use Newton's second law. So let's just do that in a different color. So first of all, the resultant is being projected up, but what's going against it is this is coming down, so that's going to be minus g sine 30. So that's the weight on the slope, and because it's going up, friction is also opposing the motion, so that's friction. Okay, and there's nothing else is helping it go up, so other than that initial projection. So that's going to equal resultant force, which is going to equal mass times acceleration. The mass of the object is 1, and times the acceleration, which we just worked on. So if I put all my numbers here, I can rearrange this, so that implies that friction will equal, take that off there, so that will be minus g is 9.8, sine 30 is a half, and since this was a minus 8, gone to the other side will become a plus 8. Okay, so just be careful on that one. So if we do that, we'll get 8 minus 4.9, and you'll get 3.1. Okay, so therefore the first thing is friction force. The friction force is going to be 3.1 newtons, and coefficient of friction of P and the plane. Now first of all, it is active, and therefore friction is going to equal mu times the contact RP, the contact mixed with the slope. So RP is going to be the same as G cos 30. We know that this is friction is 3.1 equals mu times RP is G cos 30. So if we rearrange that, therefore mu will equal 3.1 shared by G cos 30. If you put that in your calculator, that will equal 0.365. Okay, so we've done that second part. Now it goes here. Determine the acceleration of P down the plane subsequently to the instant. So basically what will happen is it will go up there, come to instantaneous rest, and then start coming down. So let's do that second part. Do that in a different color, blue. So let's do the second part. So what will happen is now it's starting to roll down with this. So I'm going to say that's going to be G sine 30. So it's coming down. Okay, the slope. And what's going to be opposing that is this friction. Now friction, when it's active, remains the same. So friction is going to be 3.1. And Newton's second law, that's going to be resultant force, which is going to call mass times acceleration. Mass of the particle is 1, and that's going to be 1a. Okay, so once we got that, that's it. We can say 9.8, that's a half, that's going to be 4.9. Subtract 3.1, it's going to give me the acceleration. And if you take this away, therefore acceleration will be 1.8 meters per second down the slope. Okay.